All right, on to 5.3. Still talking about normal distribution, but now we're going to be finding z-values based on area. We're going to be working backwards today. So we have been given a z-value, and then we find that z-value in our table, and then we find the corresponding area. Remember, the table is always to the left of that z-value. Today, we're working backwards. So you're going to be given the area, which is the number in the chart, and then you're going to find the corresponding z-value that would give you that area to the left or to the right, respectively. All right, so we'll do this first couple together. The first one has an area to the left of 0.3632. So before you even start looking, are you looking on positive z-values or negative z-values here? And how do you know? Is the answer to that a positive or a negative z-value? It is negative. How do you know it's negative? To the left of the mean. So you already know which side of your chart to look at. If you've got an area smaller than a half, it's negative because it's to the left of the mean. If you've got an area bigger than a half, it's positive because it's to the right of your mean. All right, so find on your chart in those negative z-values, 0.3632 is what you're searching for. And negative 0.35. Everybody see it there? Negative 0.35. That is the answer to that problem. Okay. Let's do one if it's to the right. If it's 10% above, that as a decimal is 0.1075. Now, if I find that in my chart, it's not going to match up because 0.1075 is to the right. And remember, what we see in our chart is to the left. So if I know 0.1075 is to the right, how could I figure out the area to the left? Right, and anytime we're doing those right problems, it's the complement. So we're going to do 1 minus this first, and that will tell you the area that you're going to search for. 0.8925. All right, so let's see here. Positive z-value greater than, let's see, 0.8925. 1.24. Sound good? Any questions? Everybody seeing this okay? Great. All right. I want you to try these two. These are the first two on your paper. I'm going to give you a clue for the one at the bottom here. I'm going to sketch this out. 95% of my data is between those z-values. So what percent is unaccounted for? 5%. And it's symmetric because it's a normal curve. So what percent are in these little tails here? 2.5. It's half of that remaining area. All right, so that 2.5 should help you on that bottom one. All right, so go ahead and take a minute. You guys can work together if you want to find the z-scores. All right, let's check them. So the top one is area to the right, so you need to do the complement first, which gives you 0.0384, and then your z-value is negative 1.77. You should find in the table for that one. How'd we do on that one? Okay. On the bottom, if 2.5% is to the left of that first z-score, that area is 0.025, and when I find that on my chart, that's where the negative 1.96 comes from. If 2.5% is to the right, I have to subtract from 1 to get 0.075. And then when you search for that, oh no, that's not right. It should be 0.975. Yeah? Why did I write a 0 there? I don't know. And then when you search for that, you should get a positive 1.96. You'll see symmetry with those z-scores because we have symmetry in our normal distribution. Any questions on those? Nada? No? Okay. Moving on. I'm just going to jump right to the one on your next slide there. Find the z-score that corresponds to a given percentile. So P sub 10 means the 10th percentile, which means 10% of the data, or 0.10, is below the value that you're going to find. So we're going to find 0.10 on here, get as close as we can. You know it's going to be in your negative z-scores because it is a number smaller than 0.5. 0.10, let's see. And we're not going to have exactly that number. Do you guys see it's going to fall between negative 2.33 and negative 2.32? Okay, when we're doing percentiles or something below, we're always going to pick the lower one. Okay, we're going to pick the value below that 10%, because if I pick the 0.0102, that's really above 10%. Does that make sense? So we want something below 10% or the closest to it, and negative 2.33 is going to be the value we find for that. Okay? All right, try the next two. Find the z-score that corresponds to the percentile. All right, when you're ready. So neither of these are exactly on the chart, so we're going to pick the z-value that's just below them, which gives me negative 0.85 and 2.32. Okay. Did I mess one of them up? You guys are looking at each other.
I got for number 2, negative 2.06.
Oh, what did I do? Hold on. Negative 2.06 seems kind of small. For 0.2, we're looking at 0.02. I think you're using 2% instead of 20%. Right? You with me? No?
Sorry.
If you move that decimal 2 spaces to the right, it's actually 0.2%. Or which one were you looking at? Negative 2.0. Yeah. It's 1% and 2% versus 19 and 20. You're just off by a decimal. I gotcha. Okay. Other questions? Yeah?
Does that make 10% though?
Oh, I missed that one out. Okay, well, let's fix that one then. Where's 0.1 on my chart? I looked at the wrong one. Negative 1.29? Yeah. Sorry. It would help if I did the example problem right before I made you guys do it. It's my bad. Better? Okay. Yes. All right. Yeah, you should be looking for this exact decimal here. You shouldn't have to like convert it or move decimal points left or right or anything like that. I just looked at the wrong one for that one. Okay. Questions, percentiles, z-scores. All right, moving on. Okay, so z-scores really don't mean a whole lot to us as far as actual data goes. So we've used this formula already before. To get a z-score, we took a data value and converted it by subtracting the mean and dividing by the standard deviation. If you take this formula and solve for x, so get x by itself, you can use it the other way. You can use a z-score to figure out what data value that corresponds to in your set. So just think back to like algebra 1. How can I get x alone in this equation? What do you do first? You don't know how to get x alone in an equation, guys?
Multiply by the standard deviation.
Yep.
And add
Perfect. Thank you. Okay, so they're both mu's, but we're multiplying by the denominator, multiply by the standard deviation, and then add on the mean. So your formula to solve for x, if you are given a z-score in a data set, is the z-score times the standard deviation plus the mean. Okay, so we'll do just a couple of these. In this problem, it says a veterinarian records the weights of cats treated at a clinic. The weights are normally distributed with a mean of 9 pounds, a standard deviation of 2 pounds. Find the weight x corresponding to each z-score and interpret the results. All right, so let's label some things we know to start. We know the mean is 9, and we know the standard deviation is 2, and we're given a z-score. So we're just plugging it into our formula for x. So for 1.96, I would do 1.96 times my standard deviation 2 plus my mean 9. So 1.96 times 2 plus 9. And you get 12.92 is a piece of this data, or within the data set that we were given. Everything's measured in pounds here. So it represents a cat that weighs approximately 12.92 pounds would be within that z-score or below that z-score. All right, let's do one more. If I have a z-score of negative 0.44, negative 0.44 times my standard deviation 2 plus my mean. (8.12 pounds). If you have a standard deviation that is positive, you should have a data value that's to the right of the mean. If you have a standard deviation that's negative, you should have a data value that is to the left of the mean. So that's a good way to check it, right? Because that's what standard deviations tell us. Positive is to the right, negative is to the left, above or below. Questions converting to an x. Great. Moving on. Let's go ahead and do this one. You know, actually, I'm going to let you guys try this one. Okay. Think about what's left in the tails. That can help you here. It says many investors choose mutual funds as a way to invest in the stock market. The mean annual rate of return for a large growth during a recent 5-year period was 12.1%, standard deviation of 1.8%. Between what two values does the middle 90% of the data lie? So in order to do this problem, you have to find those z-scores first that are on either side of your 90% that they're giving you, right? And then from there, once you have the z-score, you can find the x values. All right, go ahead and try it. Okay. So area that you're looking for on your chart to get those z-scores, if 90% of the data is in the shaded region, that means there's 10% unaccounted for, 5% on each side. So to get this first z-score on the left, you're looking for area below 0.05. To get the z-score on the right, 0.95. Now, when you guys look in the chart, 0.05 is not exactly in there, but look on the chart between 0.64 and 0.65. If you look at those two numbers, it's actually right in the middle of those two. It's exactly in the middle. So that's why instead of negative 1.64 or negative 1.65, I added that extra decimal place because I can get that exact number because on my z table it's between two numbers. Exactly. Does that make sense? Now, it might not have made a big difference in your answer. I just rounded to one decimal place there because that's what the original problem rounded to. But if you do find a z-score that's right in the middle, you want to go ahead and find the average of those two. It makes it a little bit more accurate. Again, you see symmetry with those z-scores because we have our symmetric distribution here in our normal curve. What questions do you have on this? Yep. So I know that 5% is in this little tail. So I just did 100, 1 minus 0.05, that 5%. So just like what we do when we want area to the right, we do 1 minus the area that we have, which is 0.05. Other questions? Okay, let's practice a couple more together just to make sure we're good with this. It says, scores for the California Peace Officer Standards and Training Tests are normally distributed with a mean of 50, standard deviation of 10. The agency will only hire applicants with scores that are in the top 10%. What is the lowest score an applicant can earn and still be eligible to be hired by the agency? All right, so labeling things I know. I know my mean is 50. I know my standard deviation is 10. And I know I want my scores to be in the top 10%. So the area that we're looking for, first of all, I need to do 1 minus the 10%, I guess. We do that first. 1 minus 0.01 or 0.1 gives me 0.90. And because we want it to be in the top 10%, not at the top 10%, we want anything bigger than 0.9 is what we're going to look for on our chart. Okay. The smallest value that is larger than 90% puts me in the top 10%. So on your table, you're going to look at your positive z-values. And we are looking for the first number that is above 0.9. Okay. So let's see here. First number that is above 0.9. I have 0.9015. That looks good. Okay, so 1.29 is the first z-score that would correspond with the top 10% of the data. Once you know that, you can convert it to an x value now. So x equals z-score times standard deviation plus the mean. 1.29 times 10 plus 50. And 62.9 is the score on the test that would put the applicant within the top 10% of all people that take the test. Okay, let's try the next one. In a randomly selected sample of women ages 20 to 34, the mean, just go ahead and start labeling, is 179 milligrams per deciliter. And the standard deviation is 38.9 milligrams per deciliter. Assume the total cholesterol levels are normally distributed. Find the highest total level a woman in this age group can have and still be in the bottom 1%. So bottom 1%, that's to the left of 1%. So what we're looking for is an area less than 1%, 0.01. Okay, so it's definitely going to be a negative z-value that we're looking for, and you want the first z-score you can find that is smaller than 0.01. And I've got a 0.0099. It's pretty close. So negative 2.33 is the first z-score that will be in that bottom 1%. Converted to an x value. Z times standard deviation plus my mean. And I get about 88.4. And what was this? Milligrams per deciliter. Okay. Good? This making sense? You guys with me? You're quiet today. I don't know if that's a good thing or a bad thing. Okay. The last two slides on your paper are kind of a summary of this lesson, putting all these things together. So you're going to use this chart and its information to answer the 6 questions. I'm going to put all 6 of these on the whiteboard. I'm going to assign maybe 1 or 2 of you each one of these, and then we'll get them up. We'll check them. As soon as they are all up and correct, we are done with our lesson for today. Okay? All right, so go ahead and get started. I'll come around and tell you which one you're going to be in charge of in a minute. Okay. And remember, if something is below 50%, it's a negative z. If something is bigger than 50%, it is a positive z. Give me 1 second.